In this sample problem, we are asked to write down the reaction quotient for this chemical reaction, which is the decomposition of dinitrogen pentoxide. In order to write down the reaction quotient for this chemical reaction, first we have to make sure this chemical reaction is balanced. So now let's take a look. We have 2 nitrogen on the left hand side and 1 nitrogen on the right hand side. So we should put a 2 on the product side, just to balance the number of nitrogen. Then we look at oxygen. On the reactant side, we have 5 oxygen on the left hand side, and on the right hand side, we have 2 times 2, 4, plus another 2, which is 6. So we have 6 oxygen on the product side and only 5 oxygen on the reactant side. So that means we need more oxygen on the left hand side. And it's not obvious that we have 5 oxygen versus 6, and what should be the coefficient. So for example, let's give it a shot. Just put a 2 in front and see what will happen. Now we look at this reactant again. We have 4 nitrogen atoms on the reactant side, and we only have 2 nitrogen on the product side. So we should change this 2 to a 4, so that we can balance the number of nitrogen. Okay, so now we have oxygen left. We have 2 times 5, 10 oxygen on the left hand side, and we have 4 times 2, which is 8, plus another 2 oxygen. So once again, now on both sides of the reaction, we have 10 oxygen atoms. So now this chemical reaction is balanced. We're ready to write down the reaction quotient for this reaction. The symbol for reaction quotient is QC equal to the molar concentration of the product, NO2, okay, and the stoichiometric coefficient will go to the power of the molar concentration, in this case of 4, times the concentration of O2 to the first power, which we can ignore. Then we have the concentration of the reactant side, which is N2O5 to the second power. That's it. This is the reaction quotient for the decomposition of dinitrogen pentoxide.